Shaitanirrajim. Bismillahirrahmanirrahim. This is actually our second class on air and noise pollution control. And yes, so in this class we will try to understand some of the concepts related to air pollutants, their sources and effects, and the subsequent outline will cover fundamentals, criteria air pollutants, their sources and effects, and as well as non-criteria air pollutants, their sources and effects. So we will also try to understand the mechanism with which air pollutants actually come in contact with the living beings and non-living beings and pose harm to on them. So the last actually, especially the last content, reporting of air pollution data. This is actually more related to the practical part. So I have tried to included it into this session so that we could also cover some of the descriptive comments, contents of your practical part. So let's start uh, this session by studying about air pollutants. So in the previous class, I have already explained to you what are the air pollutants. Actually, air pollutants are these are the substances that are which are present in the air in abundant quantities, in sufficient quantities, in heavy amount. However, what makes them air pollutant is their concentration. That is one thing. Second one is their nature, that they are toxic in nature. And third one is their contact. So when a substance that is present in a sufficient quantity or in large quantities in the air or in the atmosphere, and it has a toxic nature, and when it comes in contact with living beings and non-living beings, so upon contact, physical contact with the objects or with any component of the environment, so they pose harm. So these substances can be solids in nature, can be liquid, or can be gaseous in nature, right? However, they can be from natural sources or from human sources. If you recall your previous lecture, that was the introductory lecture in which I had, in few slides, I had tried to present a comparison uh, between the amount of their quantities that are being generated from the natural sources and man-made sources. So we had concluded that natural sources are the major contributor of these air pollutants compared to the man-made. So here is another definition that you can read by yourself. So if we see their types or their classification, so we can generally classify the pollutants into two classes. One is criteria pollutants, or we can also call them major pollutants, and another one is non-criteria pollutants or minor pollutants. So other than these two classifications, there is another classification, that is primary and secondary. So before discussing about the criteria and non-criteria pollutants, I would like you to know about the primary and secondary pollutants. So primary pollutants are those which are directly emitted from the sources, right? And the secondary pollutants are those which are formed in the atmosphere as a result of chemical reaction of primary pollutants, right? So it means that we can say that the primary pollutants are the source of secondary pollutants. It is also notable that some of the primary pollutants can also be secondary pollutants, and we will see these concepts in the coming slides. So now let's come to this the classification that I have included in this slide, which is criteria pollutants. You can also, before knowing about criteria, you need to know what is a major pollutants. Major pollutants are those which are present in the air in large quantities, right? And they can pose harmful effects on human health, on animal health, on plant health, as well as on uh, non-living things like structures, buildings, etc. Right? Since they are major pollutants, so they have been under watch or they have been under continuous monitoring since the beginning of 20th century. So based upon those observations or continuous monitorings, uh, so scientists have developed uh, some standard values for these pollutants. So if their concentration increases or rises above those standard values, so they would be considered as much more harmful to the human health or to the living beings or to the non-living beings. If or if their concentration falls below those standard values or one or two values or a range of values, so in that case, they would be harmful, but not up to, but not that much, right? Now those values are called standard values or the criteria values, right? Since these pollutants have been considered in setting out those standards or criterias to maintain the health of our environment or to ensure the sustainability in the quality of our environment. That's why these pollutants are called criteria pollutants. And you can see I have included one figure here to give you an idea what I mean by criteria pollutants. So these include carbon oxides of sulfur, nitrogen, especially sulfur dioxide, nitrogen dioxide, carbon monoxide, lead, and particulate matters, and ground level ozone, right? We will see through each of these criteria pollutants one by one, their sources, their effects on living beings and non-living beings, and then we will move on towards non-criteria pollutants. So the first of these criteria pollutants is particulate matter. Particulate matter is not a single entity. So I had told you that the criteria pollutants can be primary or secondary. Since particulate matters is not itself a single identity, it's a result of a combination of various substances. So these substances can be gaseous in nature, like oxides of sulfur, oxides of nitrogen, oxides of carbon. These can be liquid in nature, like moisture contents, or these substances can be solid in nature, like dust, metal particles, mineral particles, soot, mist, and dirt, and acid fumes, etc. So when these substances, either liquid, solid, or gaseous in nature, uh, under some feasible conditions, when they come in contact and under some feasible condition, they form particulate matter. So since particulate matters are the result of combination of various substances, so they can be of various sizes, right? However, uh, those particulate matters which are larger in size, so they can be visible, they can be dark in color, and you can see them with your naked eye. However, those particles which are smaller in size, you can't see them with your naked eyes. Even you need to use an electron microscope to study them, right? So if we talk about their size, they can be smaller in size or they can be large in size. And with regard to their ill effect on the living beings, smaller the size of a particle, the more deep it can go into your body or body of a living being, or it can go deeply into your lungs, and therefore greater is the potential to affect the health of a living being, right? Besides various sizes, two sizes are of paramount importance. One is PM10 and second one is PM2.5. So why these are very important and why only these two sizes have been chosen? So because of their degree of harmfulness on human health right? So PM10 includes those particles with diameters vary varies between 10 micrometer to less or to small, right? While PM 2.5 includes those particles or particulate matters whose size varies between 2.5 micrometers or small, right? Now, since their size is very important because the degree of harmfulness from particulate matter is directly linked to their size. Smaller the size, more will be the degree of harmfulness. So we need to have some idea that what is actually meant by 2.5 micrometer or what is meant by 10 micrometer. So through this figure we can understand this concept. If you see this one is our here, right? So the average size of our hair, I mean size mean the diameter is between 50 to 70 micrometer. If you consider the diameter of our hair is 70 micrometer, so compared to this size, the size of a 2.5 micrometer particulate matter is 30 times less than this 70 micrometer, right? And likewise, PM10 is 7 times smaller in size compared to our hair, right? You can also make a comparison of these particulate matters with the sand particle that has a size of 90 micrometers, right? So if we talk about the sources of particulate matters, as I have told you, a particulate matter can be a primary pollutant or it can be a secondary pollutant, or there can be other classification for its sources. One is that even if a particulate matter is a primary pollutant, I mean, if a particulate matter is directly emitted from the source can be natural or the source can be an anthropogenic. So, if we uh, if we talk about the anthropogenic sources, so the particulate matters can be emitted from construction sites, from uh, dust roads, I mean unpaved roads, or fires, right? Or from natural sources, the PM or particulate matter can be uh, emitted from a forest fire, right? And forest fire is the major contributor of the particulate matter. And in terms of their number or their quantities, again, natural sources are the major contributor of particulate matter. As you can see from here that almost 2.9 or almost 3 petagrams of particulate matter is being added to the atmosphere from the natural sources, and especially from forest fire. Compared to that, anthropogenic sources contribution is only 110 uh, teragrams, right, per year. So these were the statistics for the primary particulate matter, though it's a criteria pollutant, but at the same time, particulate matter is a primary pollutant. Now, if we see what can be the source for the secondary particulate matter. So the secondary sources of particulate matter include uh, the conversion of hydrogen sulfide, sulfur dioxide, nitrogen dioxide, and ammonia and other hydrocarbons, right? So uh, when since these pollutants, I mean, these are gaseous in nature, oxides of sulfur, nitrogen, hydrogen sulfide, and ammonia. These are gaseous in nature, and when they are emitted into the atmosphere, so in the presence of moisture contents and light, they react, and then, especially in the presence of moisture content, so these gases actually accumulate to form particles, and then those particles act as particulate matter, right? So if we talk about the formation of secondary particulate matters, especially from hydrocarbons, so hydrocarbons they react in the atmosphere, and their byproducts actually condense and to form particulate matter, right? Uh, if you see the quantities of secondary particulate matter, so from natural sources or natural sources of secondary pollutants yield about 240 teragram NOD. However, anthropogenic sources has contribute more to about 340 teragram compared to the natural sources, right? The other direct source of primary particulate matter is dust. So the dust particle actually, when they are picked up by the wind or the moving air or the flowing air, so they are actually segregated based on their size. So since I have told you that particulate matters can be of various sizes, uh, so their size actually depends upon their source. So if the particulate matter is from dust particles, so its size can vary between zero point 0.5 to 50 micrometer. From and the particulate matters from sea salt uh, have general size that varies between zero point zero 0.05 to zero point 0.5 micrometer. If the particulate matters are formed as a result of photochemical reactions, so these are the secondary particulate matters, their size is even gets further smaller, uh, that less than zero point 0.4 micrometer. And the particulate matters from smoke and fly ash particles, so their size varies between zero point zero 0.05 to 200 micrometer, right? So these were the classification or the information related to size of the particulate matters. Uh, this fact I have been repeating again and again that the size is very important if we talk about particulate matters. So smaller the size, greater will be the harm, right? So that's why I have presented this information in this lecture. So, if you see the mechanism by which the particulate matters are removed from the atmosphere, so actually, if we categorize it into two, like small particles and large particles, the small particles are removed from the atmosphere by accretion to water droplets. So actually, the particulate matters grow in size, uh, and uh, when they come in contact with water droplets, so they grow in size and then precipitate. Uh, Likewise, large particles they are removed by direct washout. as raindrops, right? If we see their effect on, especially on human health, so their effect actually varies depending upon their size, right? Because smaller particles pose more harm on health compared to uh, the larger particles. Uh, if their concentration, if they are, even if the particulate matters available in the atmosphere in any size can uh, pose a risk of respiratory or cardiovascular disease or cancer-related death, as well as pneumonia, lung function loss, and asthma, right? Or we can say, if a person exposes to the particulate matters, they can affect both your lungs as well as your heart. So, various scientific studies have linked particulate pollution exposure to a variety of problems, uh, including non-fatal heart attacks, irregular heartbeat, premature death in people with heart or lung disease, asthma problem, and decreased lung function, right? So these are some of the problems that are associated to these matters, right? So the next pollutant is sulfur dioxide. Dioxide is another. I mean, it's not only the sulfur dioxide; it's the sulfur oxides, because sulfur is present in the atmosphere in 3 to 4 formats. Uh, However, the SO2 is very important because of its impact, right? So it's a colorless gas which is very toxic in nature and highly reactive, and it is uh, emitted from the burning of fossil fuels, right? So fossil fuels are burned in industries and in the automobiles. So it is mainly these are mainly the major sources of oxides or sulfur dioxide, right? It is also released in the industrial production of sulfuric acid, right? But it gets even more, harmful when it come in contact with the water vapors, because water vapor and sulfur dioxide's combination produces or forms sulfuric acid and other sulfates, right? Okay. So if we see that how does SO2 get into the air, so I have told you that burning of fossil fuels is the major source, uh, and the smaller sources of SO2 include industrial processes such as extracting metal from ore, natural sources such as volcanoes and locomotives, ships, and other small vehicles. So these are the major sources of sulfur dioxide. So sulfur dioxide can affect both health and the environment, right? Uh, before going into its sources, into its impacts, let's talk a little bit more about its sources. The sulfur oxides can be, I have told you, like particulate matter, sulfur oxides may be both primary and secondary pollutants, and their sources can be power plants, industry, volcanoes, and other oceans and the oceans. So they emit oxides of sulfur, right, directly as a primary pollutants. So the combustion process also emit sulfur oxides, and if you want to see the chemical reaction by which sulfur oxide, especially the sulfur dioxide, is formed. So the when sulfur containing fuels are burnt, so in the presence of oxygen, so they emit sulfur dioxide. So what we can learn from this reaction is that uh, the amount of sulfur dioxide will be double that of sulfur, right? It means that if 1 gram of sulfur is burnt, so it means that 2 gram of sulfur dioxide will be emitted into the atmosphere. So the other sources of sulfur dioxide include biological decay processes, uh, and some of the industrial sources which emit hydrogen sulfide gas. So hydrogen sulfide gas reacts with ozone. So this is chemical ozone. Ozone. This is not the atmospheric ozone which protects us from ultraviolet radiations, but this is a chemical ozone. So this chemical ozone reacts with the hydrogen sulfide and form sulfur dioxide is formed. But sulfur dioxide does not stays much longer into the atmosphere. But uh, when sulfur dioxide combines with water, so salts of sulfates are formed. So like sulfuric acid H2SO4, and then it is washed out by precipitation, right? Now, the sulfates from sulfur dioxide, sulfates are formed. So there are two pathways for that. One is catalytic oxidation, and another one is photochemical oxidation. So the photochemical oxidation uh, uh, is more effective when some catalysts are present, like iron, manganese, and ammonia, right? Or at low relative humidity, the primary conversion process is photochemical reaction. The first step in photochemical reaction is the formation of unstable sulfur compound. So this unstable sulfur compound further reacts with oxygen, and sulfur trioxide is formed, right? Uh, so this sulfur trioxide is hygroscopic, that uh, it can readily absorb moisture contents, and when it absorbs moisture contents, so sulfuric acid is formed, right? And this reaction is actually one of the major source for acid rain, right? That is a phenomena mostly observed in the industrial areas. If we talk about oxides of the sulfur, it can be sulfur dioxide, trioxide, right? They're acids, salts, and salts of their acids. So their effect SO2, the effects of SO2 and SO3 are also treated together. And there, as I have told you, especially the sulfur dioxide, it can affect both humans and the environment as a whole. So short-term exposure to sulfur dioxide can harm the human respiratory system and make breathing difficult, especially people with asthma problem, particularly children, are sensitive to these effects of sulfur dioxide. Sulfur dioxide emissions that lead to high concentrations of SO2 in the air generally also lead to the formation of sulfur oxides, or these oxides actually react uh, with the atmosphere or other compounds which are present in the atmosphere and form small particulate matters, right? And I have told you in the previous slides that these particulate matters enter into your lungs and they can cause health problems. As far as their environmental effects are concerned, so at high concentrations, so gaseous sources can harm trees and plants by damaging uh, their leaves and decreasing growth. So they also contribute to acid rain. And visibility is also another issue which is linked to the sulfur dioxide. Like when sulfur dioxide results in the formation of particulate matter, so the particulate matter decreases the visibility. If you see the results of some previous studies, uh, so the results reveal that exposure to the concentration more than 350 gram per cubic meter uh, can cause a serious health issues, right? So the next pollutant or major pollutant or criteria pollutant is nitrogen oxide. Nitrogen oxide is also a primary pollutant. It is also a criteria pollutant, or it is also a major pollutant because oxides of nitrogen are directly emitted from the burning of fossil fuels. They can also be generated from natural sources as well as from anthropogenic sources. From anthropogenic sources, these oxides of nitrogen are emitted when air is heated to a high temperature, such as in the automobile cylinders or in the furnaces or power plants and industrial boilers, right? The oxides of nitrogen, especially nitrogen dioxide, is very reactive gas, and it is abundantly present in the air. Uh, this gas is reddish brown in color uh, at high concentration, while at low concentration it gives a brownish yellow color, right? And if its concentration increases 5 ppm, so it gives a pungent sweetish smell or odor. So nitrogen actually, which is abundantly present in the air in the form of nitrogen as well as in the form of other oxides like nitrous oxide and nitric oxide, nitrogen dioxide. So these are highly reactive, and some of the byproducts uh, or the secondary pollutants that nitrogen oxides contribute to are the formation of nitrogen dioxide, nitric acid, smog, and acid rain. Uh, let's further talk about its sources, especially from if we talk about the natural sources. So the bacterial action in the soil release nitrous oxide to the atmosphere. So this nitrous oxide reacts with the oxygen atom, and nitric oxide is formed. Uh, so this actually, the atomic oxygen results from the dissociation of ozone. The nitric oxide further reacts with ozone to form nitrogen dioxide, right? Nitrogen and oxygen, these are abundantly present in atmosphere. They don't react at ambient conditions because they can only react when temperature reaches to around 1300 degrees Celsius or 1600 Kelvin temperature. And then again, nitric oxide is formed. Uh, if we talk about emission of nitrogen oxides from combustion process, if the combustion gas is rapidly cooled after the reaction by exhausting it to the atmosphere, the reaction is quenched, and nitric oxide is the byproduct. So this nitric oxide reacts with the ozone. I mean, this process actually repeats, and nitrogen dioxide is formed. So, like other pollutants, major pollutants like particulate matter, sulfur dioxide, nitrogen dioxide also pose some great health concerns, right? Uh, Breathing air with the high concentration of nitrogen dioxide can irritate airways in the human respiratory system. Uh, they can cause respiratory diseases, particularly asthma, or leading to respiratory systems symptoms such as coughing or difficulty in breathing, right? While longer exposures to high concentrations of nitrogen dioxide may contribute to the development of asthma and potentially increase susceptibility to respiratory infections. Uh, if we see exposure to specific values of nitrogen or specific concentrations of nitrogen dioxide, like its concentration above 5 ppm for 15 minutes results in cough and irritation of the respiratory tract. While the continuous exposure may result in accumulation of fluid in the lung, and the average concentration, if we see in tobacco smoke, is approximately 5 ppm, right? The next major pollutant is carbon monoxide. Carbon monoxide is uh, uh, so before going into uh, detail about the carbon monoxide, so I want to add some more information about nitrogen oxides. So, other than health effects, nitrogen oxides also has have some environmental effects, like nitrogen dioxide and other noxes interact with water, oxygen, and other chemicals in the atmosphere to form acid rain. Or so Nitrate particles that result from NOxes make the air hazy and difficult to see through, right? And NOxes in the atmosphere contribute to the nutrient pollution in the water sources or waterways. The next pollutant is carbon monoxide. So carbon monoxide is also one of the major and criteria pollutant. It is also very dangerous. It is colorless, odorless, and poisonous gas, and slightly lighter than air. So it also comes from natural as well as anthropogenic sources. From anthropogenic sources, it comes from the burning of fossil fuel, especially partial burning of fossil fuels. And if we see the contribution from anthropogenic sources, so vehicle exhaust contributes roughly 60% of all CO emissions nationwide and up to 95% in urban areas, right? So actually, carbon monoxide is the greatest source. If we see its sources, so we can divide it into indoor sources and outdoor pollution. So the greatest source of CO, carbon monoxide, to outdoor air are cars, trucks, and other vehicles that burn fossil fuels, or a variety of items in your home, such as unwanted kerosene and gas, space heaters, leaking chimneys and furnaces, and gas stoves also release carbon monoxide and can affect air quality indoors. There, carbon monoxide also emit is being emitted from the natural sources, like the natural anaerobic decomposition of carbonaceous material by microorganisms release methane to the atmosphere, and carbon monoxide is actually generated during the oxidation of this methane. Uh, so this oxidation process completes in uh, more than 41 steps. So the reaction actually starts when methane reacts with a compound or of oxygen and hydrogen, right? And then 39 more reactions actually take place in the presence of oxygen and sunlight, and then finally carbon monoxide actually is generated, right? And the other information that is related to these chain of reactions is presented here in the last bullet. I have already told you about its sources, uh, but in terms of its quantities, you can see here uh, how much quantity of carbon monoxide is being released as a result of incomplete combustion of fossil fuels. But besides is its release from both anthropogenic and natural sources, study of the last 20 years have revealed that its concentration is not increasing in the atmosphere because of It's not only being released into the atmosphere, but at the same time, uh, similar amount or the same amount of carbon monoxide is being used in other processes. So, like other air pollutants, uh, this gas, carbon monoxide, is very harmful for human health. Even when a person is exposed to a concentration more than 5,000 ppm for a few minutes, right? So, carbon monoxide actually reacts with the hemoglobin in the blood to form uh, carboxyhemoglobin. Carboxyhemoglobin is a substance or chemical which promotes the absorbance of carbon monoxide. Uh, the formation of carboxyhemoglobin increases the affinity for carbon monoxide than for oxygen. So it means that the formation of carboxyhemoglobin deprives the body of oxygen, and at when carboxyhemoglobin's concentration uh, level rises to 5 to 10%, so it affects visual perception, mental and ability to learn are also impaired. And a concentration of 50 ppm of carbon monoxide for 8 hours will result in uh, carboxyhemoglobin's concentration of about 7.5%, right? And the persons with heart disease, if they exposed to the concentration of carboxyhemoglobin of 2.5 to 3%, so they will not be able to perform certain exercises as well as they might in the absence of carboxyhemoglobin. Similarly, a concentration of 20 ppm of carbon monoxide for 8 hours will result in carboxyhemoglobin level of about 2.8%, right? Or the important thing to note is that the average concentration of carbon monoxide inhaled in cigarette smoke is 200 to 400 ppm, right? It means that especially the sensitive populations are those with heart and circulatory ailments, chronic pulmonary disease, uh, and those with conditions that cause increased oxygen demand, such as fever from an infectious disease. So these those populations are very sensitive to to the exposure with the carbon monoxide. We will continue our lecture in the next session. So up till now, we have covered some of the major air pollutants, including particulate matter, carbon oxides of sulfur and nitrogen, and carbon monoxide. So let's start another session and try to complete cover the remaining pollutants. Thank you.